Although simulation may sound like a highly scientific term and probably not quite related to our daily life, it is actually affecting most people. For example, you may have heard of something like candidate has a probability of 85% to win the president election, or player has a probability of 60% to win the game, etc. Simulation is everywhere. In business, companies build simulation models to predict which marketing or investment strategy is the best. In education, simulation models provide the students with real-world experience while in the classroom. For entertainment, companies have released several VR devices that will make it hard to tell virtual from reality. Even in presidential elections, multiple websites like the famous 538.com have developed lots of highly simulated models that can predict the future president of the United States. Since we found that the 538.com already had a prediction that the Warriors has a higher probability of winning the champion of NBA this year, we decided to build our own model and compare the results with theirs. 538.com implements the ELO rating in their model, which essentially gives a rating of each team to reflect its strength that is updated after each game. On the contrary, we thought of a more efficient way to predict the results. We hand-collected the game history from this regular season between each pair of possible rivals in playoff games. In short, we're trying to use what happened in regular seasons to predict what will happen in the postseasons.
We first wanted to build a model that as long as we put in all variables, we would be able to get who is the championship in each run. If we have tens of thousands of runs, we would be able to get the probabilities that each team wins the championship. However, we kept on getting the message like this. So basically, Sigma is prompting us to pay for their upgraded version to have more nodes and events. And we checked and it's like hundreds of dollars, so we decided to develop a simple model that simulates a single best-of-7 series. This is the event graph that we came up with our simulation model. We have a team left and a team right in our simulation model. It has 4 variables. 2 of them, which are L and R, are the scores of a team in a game. For example, if team left scores 105, then L equals 105. And left and right are their scores in a series. For example, if team left won 3 games, then left equals 3. The model consists of 3 events. The first event is our initialization event that sets all variables to 0. The start and iterate events serve similar function to simulate one single game. First, we determine the score of each team by assigning L and R new values by distribution function, which in our case is normal distribution. And if L is greater than R, left gets added by 1, and if R is greater than L, right gets added by 1. The only difference is that the start event resets the series score to 0. The start event goes to iterate event after simulating the first game and reschedules iterate event as long as no team reaches a series score of 4, which means they have won the best-of-7 series. If a team wins 4 games, no more iterate event is scheduled. Instead, a start event is scheduled, resetting the game series score to 0. Another important part of our simulation is to collect the data. To fit our data into a normal distribution, we need means and standard deviations for each matchup. The data collection part is dull and dry. We spent lots and lots of time doing it. We simply look up the regular season matchup history between each 2 combinations of playoff teams and put them in Excel to get the mean and standard deviation. The picture shows the data of 3 combinations of teams we collected. In total, there are 120 combinations for all 16 teams in playoffs.
That's a foul! Yes! No more. That's something. No.
sports are complicated. Current simulation techniques could hardly imitate a game completely. Therefore, only using data from regular season can produce an accurate prediction on the champion of 2017 NBA championship.
Accountable for spewing out false forecasts and making bad predictions.
At the end of our simulation, we compare our results with the prediction of 538.com, a website that uses ELO power ratings as their primary model for simulation. The results from our simulation shows that Golden State Warrior has a chance of 43.4% winning the champion. The Spurs has a chance of 20.8% winning the second place, and the Wizards winning the third place with a chance of 13.4%. On the other hand, 538.com gives a prediction of Warrior winning a chance of 59%. Going down the list, our prediction matches the predictions of 538.com in that the order of the first place and the second place are the same, while the third place different from each other, and the probability of winning varies as well. However, there are still too many factors that could not be simulated in order to predict the winner of 2017 NBA championship. Home court advantages, biased referee, injuries, and unsportsmanlike conduct are all factors that aren't so easy to predict. Based on regular season matchup histories, our simulation has done a pretty decent predictions.
Oh, and it goes in!
To conclude, our simulation proves that matchup histories could give decent information about the winner of 2017 NBA championship. Although just using matchup histories from 2017 regular season provides a small sample size, the simulation runs more efficiently without a huge pile of data.
It's over! The Cavaliers are NBA champions! The drought is over! The curse destroyed! 52 years of torment and anguish has been washed away!